First, we'll go over a block diagram of our project. The first thing we'll do is to connect our personal computer with the FRDM board and the Arduino board. This provides power, code, and data to both boards. On the FRDM KO46C board, it will do mainly two things, which is real-time scheduling and then UART. The UART will be from UART port 0, and then it sends a tuple of TIDE data. The Arduino Mega receives the UART data from its serial 1 port, and then it decodes the data and processes the data. Finally, it writes about the algorithm to showcase the TIDE. Then we have the Adafruit LED strips connected with the power, ground, and digital pinouts of our Arduino Mega board. It receives instructions and showcases the LEDs as the TIDE we needed. Here we'll go over the code a little bit and show a little demo of our testing for the UART. This is the UART code provided by ECE3140. And then we have a short delay and medium delay, as well as the real-time scheduling time with the start time and the deadlines. Then we have the LED showcase of the TIDE, which controls the onboard LED according to the trend. And then we have our 6 real-time processes that controls the UART sending as well as the LED trend data. Finally, in our main, this is our test cases, and we'll be testing out if the real-time scheduling is working by looking at the onboard LEDs. This is our 2 board structures. These are the UART 0 pins on the board and the ground, and these are the serial 1 pin and the ground on the Arduino board. The LEDs are not connected yet. We'll connect them later. Here in the Arduino code, we have receive buffer, which corresponds to the length of the data sent, and we have a message buffer. And then we define the baud rate, receive the data from serial 1, and then read byte from serial 1 into receive buffer. So now we'll see the UART data sending. In this code, we have the Arduino code, and we're now uploading the code onto the Arduino Mega board. Now, by looking at the serial monitor, we'll be able to see something is written out, but it hasn't received anything yet. Now we have seen received, and then there's some numbers after that. This means we have successfully received the data we're supposed to send. And then that means our UART communication is working successfully. In this part of the testing, we're testing the real-time scheduling by looking at the LEDs. It should be 2 red, 3 green, and then 1 red. The results are correct. After the basic function testings, we're now putting the LED strips onto the board and connect them together. This is a full version demo of our TIDE clock project. Here you can see that the number of pixels that turns on corresponds to the level of the TIDE, and the changing of intensity is the trend direction of the TIDE. It is now going up. The level and possibly the trend changes after a while. It will update by itself. Now the trend is going downward, and then the level is very high. The trend is still downward, but the level is lower. Now we have a very low level and then the upgoing trend. And this is the end of our demo.